K is your scale factor. That's how large or smaller something becomes. Because you could have a dilation where everything gets reduced by half. So the rule for this dilation stuff is not all that complicated. You're multiplying the x and y coordinate by the same k value. So let's look at some examples. We're going to dilate triangle ABC that's drawn for us by a factor of 3 from the origin. So 3 is our scale factor. Now let's calculate or figure out the points of ABC. So A is at 2, 3. B is at 1, 5. And C is at 5, 4. Now to get A prime, B prime, and C prime, we're going to take each of those coordinates and multiply them by 3. So 2 times 3 is 6, 3 times 3 is 9. For B prime, 1 times 3 is 3, 5 times 3 is 15. For C, 5 times 3 is 15, and 4 times 3 is 12. So C prime is 15, 12. So then we're going to plot those points. So 6, 9, 1, 2, 3, 4. So that's A prime. B prime is at 3, 15. So it's easy to mess this up, so just make sure you are taking your time and counting. So that's how the dilated triangle looks, and you can see that it's kind of the same shape, but it's obviously a different size. Now, a second example, our scale factor is 0.5. So we're going to take these coordinates and multiply them by 0.5. So A is 1, is 6, 8. B is 3, 15. And C is 16, 10. Now we're going to multiply each of these coordinates by 0.5. So in the calculator, if you multiply 6 by 0.5, you get 3. If you multiply 8 by 0.5, you get 4. Multiplying by 0.5 is the same as dividing by 2. So we do that over here. 3 divided by 2 is 1.5. 15 divided by 2 is 7.5. 16 divided by 2 is 8. And 10 divided by 2 is 5. So then we can plot these points. So 3, 4. That's A prime. B prime will be 1.5, 7.5, so 1.5, and then up 7.5. So there's B prime, and then C prime will be 8, 5. So dilation doesn't only make an image smaller, it can also make it larger. So here are examples of that. So the properties of dilations, the first one is that all corresponding angles congruent. So after we dilate the image, the angle measurement doesn't change. Like angle A and angle A prime here are the same measurement. And then the corresponding sides are parallel. Now the corresponding sides that we have, we look at the image and the pre-image and we match up the lettering. So like we have side BA and side B prime A prime. Those two sides are parallel with each other. Okay, on the next page we're going to have triangle ABC. So A is at 2, 0. B is at 6, -4. And C is at 8, 2. So there's ABC, triangle ABC. And now we're going to use a scale factor of 1/2. So A is going to become 1, 0, and they're asking us to label that point L. M becomes 3, -2. And C is going to be point N at 4, 1. So the reason we're not using the prime notation here is because the directions tell us what these points are going to be called. Okay, we're going to show that the corresponding sides are parallel, and we're just going to do it for NM and CB here. And instead of using the slope formula right now, let's just count. So MN, if we go from M and go to N, we're going up 3 and right 1. So that's 3 over 1, which is 3. Now if we're going from B to C, we are going up 1, 2, 3, 4, 5, 6, and right 2, which also equals 3. And you should have learned in algebra that when lines have the same slope, they are parallel. So because we have a slope of 3 for both of those lines, they are parallel. We're not going to go through doing the rest of them because we're going to show that all the other ones are parallel too. So example 4 says you are making your own photo magnets. Your photo is 8 inches by 10 inches. The image on the magnet is 2.8 inches by 3.5 inches. What is the scale factor of your reduction? So I'm going to draw this out to help us figure this out. We have 8 by 10 inches, and we want to go down to 2.8 inches by 3.5 inches. So what we're going to do is we're going to take the final value and divide it by one of the original values or original dimensions. But make sure you pick the correct corresponding one. So if I'm going to use 2.8, that means it needs to be divided by 8. Or if I would have picked 3.5 first, it needs to be divided by 10. So if we put those in the calculator, we will get the same value. So I get 0.35 here, and if I do 3.5 divided by 10, you also get 0.35. So that is your scale factor for your reduction, 0.35. The final example we'll do is this one here. We're trying to find the scale factor. And the first thing we're going to do is figure out what x is. So if the whole thing is 14, and this part is 4, that means the part that's x must be 14 minus 4, which is 10. Okay, so if we know that the x value here is 10, what we're going to do is we're going to take this whole thing, 14, and divide it by the smaller part, which is 10. And that gives us a scale factor of 1.4. Okay, so again, dilations, you're either making the pre-image larger or making the pre-image smaller by a single k factor, a single scale factor that we notate as k. And you multiply everything by that scale factor. So I hope that this is a good introduction. We will talk about this more later. Make sure you hit the like button, and I'll see you later.